Hello, we'll start in a few minutes. Hi, hello everyone. Okay, we'll give it until 2:05. Let me just make a little note here. Just so that more people can join. Hi, yes, I am going to post this video on YouTube, absolutely. We're just waiting until 2:05, guys. I wrote it there at the top, then we'll get going. In your toolkit book, great. That's good news. Sorry guys, I was just away from my phone for a bit, so I'm just reading through the comments. So grade 12s are starting with sequences and series, which is basically number patterns. So I did a live on that on Monday. I did post it on my YouTube, so you can go watch it over there. We just revised grade 11 number pattern stuff. So someone is here for grade 10, that's fine, because the stuff that we're doing today is actually grade 10 content. So you will learn something if you are here. Yeah guys, I've just basically prepared these questions. These are some of the questions that we'll be working through. So don't worry, I will explain them. We're going to do them now. It's like worked examples. My YouTube channel is Miss Hanekom, but if you go to my TikTok profile, then there is a link there. Okay guys, just 2 more minutes and we're going to get started. Just let me know quickly if you can hear me speaking. There was a problem with the sound on Monday, so I just want to make sure that you guys can hear my voice. Okay guys, let's get started. Cool, I see that you can hear me. Sorry about the creaking. I'm sitting like on the edge of a bed and it makes a creaking sound. Okay, let me just put the music down a bit here. Alright, so my phone is facing away from me right now, so I can't actually read your comments. So every now and then at the end of each question, I think I'll just quickly check if any of you had any questions and then I'll answer them. So don't stress if I'm not answering your questions straight away. Okay guys, so this live is for grade 11s. We are meant to just, we're going to just revise some of the stuff that you did in grade 10 for the topic exponents. So you can see that here in my heading I've written exponents and surds. You didn't really do surds in grade 10. Some of you might have, but it's not really in the syllabus all that much. You might have just learned how to go from exponential form to surd form. And remember that surd form or surd is basically like a square root or cube root. Those are called surds. So yeah, this is the first section that you'll be doing. We are going to just be revising exponent stuff. We're not going to go into the surds because yeah, you will be taught that basically from scratch in grade 11. But what you do need to be able to do quite well is apply the laws of exponents. Stuff that you did in grade 10. All of these examples are from a grade 10 textbook. So there's nothing new to these examples. But yeah, I just thought that it's a good idea to go through some of these, make sure that you are okay on the grade 10 stuff before you start in grade 11. Also, just another disclaimer is that some schools might not start with this section. The Department of Education just sends like a schedule of topics that they that they suggest, or I should rather say they send the order that they suggest, but not all schools follow that order. Some schools do topics in a different order. So if you're going to be following along on my YouTube, for example, at my school we do quadratic equations first and then we do exponents and surds. So unfortunately I won't be able to post exponents and surds lessons right from the start of the year. I'm going to be posting all my quadratic equation lessons first, and then as I'm teaching exponents in class, I will be posting those lessons. Alright guys, so this first question, where we are applying the laws of exponents, this one is one that you probably would have done in grade 8 already, stuff like this, where you have 4a squared times 2a to the 4. Now what we need to notice here is that yes, we have numbers that we are multiplying, right? And we're going to keep multiplying them normally. This is just 4 and this is just a 2. So we're just going to do 4 times 2, and we all know that that is 8. Alright, that doesn't change. What we do need to look at is that here we have an exponent and here we have an exponent, right? Both of these, we call these, when you have a base and an exponent together, we call that a power. So here we have a power where we have a base of a and an exponent of 2. Here we have a power with a base of a and an exponent of 4. It's important that we notice that these have the same bases. Right now, whenever we do that, or whenever we see that, we remember this law, which is that a to the power of m, and it doesn't have to be an a, it can be any variable, either numbers. If you have a base to the power of m multiplied by something which is that same base to the power of n, then what we do is we keep the same base, so the base does not change, but then we add those exponents together. And I'm sure you guys know this. This is probably like second nature to you by now. Alright, so if you have the same base and you are multiplying these powers together, then your answer has the same base again, and then you just add those exponents together. So we see that we have that happening over here. We have the same base, a base of a and another base of a. We are going to add these exponents together. So we are going to say a to the power of, and you don't have to write this. Okay, you can if that will help, but you don't have to. So there we have 8a to the power of 6, because 2 plus 4 is 6. Guys, you do not multiply these exponents, you add them, and we notice that our base stays the same. We started with bases of a, and we are ending with a base of a as well. Alright, that is the answer over there. Just checking if there are any questions. Yes, this will be posted to my YouTube. I'm just going up. Okay, let's see. Okay, perfect. Let's move on to the next one. I just want to check spacing over here. I'm going to move this up slightly just so that I have a bit more space on the side there. Okay. So this question is obviously more complicated than the first one. This is also something that you would have done in grade 9 probably. Working with fractions, you are dividing by a fraction, and then we have negative exponents as well, and you see that we have an exponent of 0. Okay, so now what we need to do is, I don't want you guys to feel overwhelmed by this question. There is a lot going on, but we're just going to go through it step by step. The first thing that we need to do, or I suppose there are various ways in which you could approach this question, but let's just look at what we actually have. We notice that we have a 3 and a 4. We can't actually simplify those, alright? 3 divided by 4, that's just 3 over 4. There is no number that goes into both 3 and 4, okay, other than 1, so we can't simplify that. Here we have an a. Let's put a 1 there, because remember, if there is no exponent written, then it actually has an exponent of 1, so that could be useful. We have a b to the power of 0. Now guys, b to the power of 0, anything to the power of 0 is actually 1. So that b to the power of 0 is actually the same as 1. So you don't need to keep writing b to the power of 0. You can just know that that is 1. So all of these things we're multiplying together, right? Because they're written next to each other. That means that they are being multiplied together. So if we have 3 times a times 1 times c to the 4. We don't have to write that times 1. Okay, so now in the next, or in my first step, I suppose, I am actually not going to write that b to the 0 again. Okay, because that is actually 1. If you want to, you can write it like this. So you can put a 1 in brackets there to show yourself and to show the marker that b to the power of 0 is actually equal to 1. Okay, but you don't have to do that. So that is the first thing. Here at the bottom we have a 4, we also have an a to the 1, we have a b to the 6, and we have a c. Now guys, it's perfectly fine if you notice that you have an a to the 1 at the top and an a to the 1 at the bottom. You can cancel those out. Alright, or you can keep writing them. It's up to you. You could have done it in this step already. Okay, I rewrote them. You didn't actually have to rewrite them in any case. Okay, now, let me just draw my line here. Now remember, when you are dividing by a fraction, you actually have to tip in times. Okay, so this division symbol I'm going to change to a multiplication symbol. And now this whole fraction we need to tip. So I'm not going to simplify anything, okay? I don't want to do too much stuff in the first step. You can simplify this fraction if you want, but I'm just going to tip the fraction. Okay, so whatever was at the bottom of the fraction, 4c to the negative 1, goes to the top, and whatever was at the top goes to the bottom. Now I know that we have negative exponents, and we have a 4 and a 6 that we can simplify. We'll get to that. Okay, now what I want you guys to notice is, if there are things that you can cancel out, do it. It's going to make it easier for you to work further on. Alright. It's also going to save you some time if you don't have to rewrite the same stuff over and over again. Now remember, when you are multiplying two fractions together, now the important thing is you have to have one term at the top, one term at the bottom, one term at the top, one term at the bottom. Then you can cancel within a fraction like we did with the a to the 1 and the a to the 1. Or you can actually even cross-cancel, we call it. So in other words, you can cancel something that is at the top of your one fraction with something that is at the bottom of the other fraction. Okay, now what I want us to notice is that we have a 4 over here and we have a 4 over there. We can cancel them out. Because what we're actually doing, guys, when you are cancelling out, you are actually dividing. So if you have a 4 at the top and you have a 4 at the bottom, what is 4 divided by 4? It's 1, right? So by cancelling a 4 and a 4, you're actually just saying that 4 divided by 4 is 1. Alright, so we can do that. That will make things a bit easier for us. Let's see what else do we have here that we can possibly cancel out. I have a 3 here at the top, and I have a 6 there at the bottom. Now guys, 3 goes into itself once, right? So I can take that top 3 and I can divide it by itself, by 3. But then I must do the same thing at the bottom here. 6 divided by 3 is 2. Okay. Then we notice, alright, I have a c to the 4 over here and I have 1 c at the bottom. So if I have c to the 4 here, I can cancel out one of the 4 c's at the top with the 1 c at the bottom over there. And if I have 4 c's and I take away 1, I'm left with 3. Right? So I will be left with c to the power of 3. But don't I have a c to the power of 3 over there as well? Let's see. We can actually cancel that out as well. Okay. So now it looks a bit messy. There's lots of stuff that we've cancelled out, that we've drawn lines through. Let's actually just rewrite. You don't have to do this as a separate step, but I think it's good to actually just rewrite everything that we have now. If we're looking at this first fraction, I've cancelled out everything that was at the top. That means that I'm left with a 1. Because remember, when we're cancelling out, we're actually dividing. So when you say something divided by the same thing, you're left with 1. Okay, so if you've cancelled everything out, you're just left with a 1 at the top. At the bottom, we've cancelled out everything except for that b to the 6. Alright, so we're left with a b to the 6 at the bottom there. Now here, times. Now what I want us to do is, remember, we have a c to the negative 1 here at the top. At the bottom, we have a 2, and then we have a b to the negative 4. Now, guys, I hope that you remember that when you have a negative exponent, you can change that exponent into a positive exponent by moving the whole power, right? The base with that exponent. So if we have c to the negative 1, let me just do it in a different color here. So just want to check where is some space. Okay, if I have c to the negative 1, right, over, let's just say that that's over 1 for the sake of the example. Obviously, it's over some other stuff. Okay, if I want to make this negative exponent positive, at the moment, this power, meaning the base and the negative exponent together, remember we call that a power. At the moment, that power is at the top of the fraction. If I want to change this negative exponent into a positive exponent, I need to move it from its current position. So because it's at the top of the fraction, I'm gonna have to move it to the bottom. Now, there's nothing else there at the moment, all right? There's just that c. So when I move it, I can't just leave the top of the fraction blank. I have to write a 1. And that then, the c to the negative 1, when it moves to the bottom, it stays c. The value of the exponent stays the same. It stays a 1, but it goes from being negative 1 to positive 1. Okay, so that is what we're going to do with this c to the negative 1. We're actually going to move it to the bottom, and it's going to become c to the positive 1. But at the same time, we have a b to the negative 4 at the bottom as well. So, if I want to change this b, well, the negative 4, in fact, if I want to change the negative 4 to a positive 4, I have to move it to the top of the fraction, because at the bottom it has a negative exponent. To change it from a negative exponent to a positive exponent, I need to change its position. I'm going to move it up. Okay, so let's see. I'm going to move up this b to the negative 4. It's going to become b to the positive 4. Is there anything else at the top of this fraction? There is a c to the negative 1, but remember we're going to move that c down. Okay, so that is going to move. So in fact, this is the only thing that we're going to have at the top of our fraction. At the bottom, we have a 2. And guys, just as a reminder, 2 by itself is actually 2 to the power of 1. Does 2 to the power of 1 have a negative exponent? No, it has a positive exponent. So the b had a negative exponent, we had to move that up, but the 2 is perfectly fine. It's fine where it is. It's fine at the bottom. It has a positive exponent, so we're not going to move the 2. Okay, you only move the power that has a negative exponent. If there's anything else there, a 2 in this case, with a positive exponent, you leave it where it is. Okay, remember we had to move the c to the negative 1 down. Alright, so we're going to do that now. It's going to become c to the positive 1. And everything else that we had at the bottom, we have cancelled out. So that's actually all that we're left with. Okay, now we need to simplify this even further, because I hope you guys noticed that we have 2 separate fractions here. Usually they want 1 fraction as an answer, especially if you're multiplying. Alright, you have to write 1 fraction as your answer. But then also we have a b to the 4 over here and a b to the 6 over there. So that means that I have 4 b's at the top of my fraction and 6 b's at the bottom. So I have 2 more b's at the bottom than at the top. Right, I'll show you now exactly how that works in case you are confused. But if I take my 4 b's at the top and I cancel out 4 of the 6 b's that were at the bottom, I would be left with 2 b's at the bottom. So that b squared needs to stay at the bottom. Right, now we've cancelled everything out that we can, so let's just write this as a final answer. At the top, notice we only have a 1. At the bottom, we have a 2, we have b squared, and we have c. And that is the final answer. I just want to show you guys exactly what happens in this case, because I know that a lot of people struggle when you have a higher exponent at the bottom of a fraction than at the top. Some people struggle to understand that. So what is actually happening here, right? If you have b to the 4, I hope I'm going to fit it in here, b to the 4 at the top and b to the 6 at the bottom. I know that it was cross-cancelling here, but it is the same as if you were just cancelling in one fraction. That actually means that you have 4 b's at the top of your fraction. right? Because we know that b to the power of 4 is the same as 1, 2, 3, 4 b's that you're multiplying together. And b to the 6 is 6 of them multiplied together. So 1, 2, 3, 4, 5, 6, like that. Now notice we have one term at the top and one term at the bottom. Remember, when you multiply and divide, that does not, separate terms. So this is one term, so we can cancel out. So let's see, we have a b there and a b there. Let's cancel that out. Remember, cancelling out is the same as dividing. So b divided by b is 1. That b divided by the second b is also 1, so we can cancel them out. The third b at the top divided by the third b at the bottom is again just 1 if we work that out, so we can cancel them. Then the fourth b at the top divided by the fourth b at the bottom is also 1. So what am I left with, guys? A b times b at the bottom. And we all know that b times b is b squared. Okay, so that is where that comes from. If you are confused, if you don't know how to cancel these out, please do this. It will take you a couple of seconds just to write out 4b's and 6b's, cancel them out, and then you see very clearly. You're left with a 1 at the top because you've cancelled everything out, and a b squared at the bottom. Okay, I'm just going to read comments quickly. Sherlyn, I see that you don't understand. Can you let me know what you don't understand? This will be uploaded to my YouTube, yes. Hi, Robin. I don't know if you're still here, but thanks for coming. Yes, when dividing the same base, we subtract the exponent, yes. Okay, this is pure maths. Let's see. Times is plus, divide is minus. Exactly, that's perfectly, or that is exactly correct. Let me show you quickly here. If you wanted to just, instead of the cancelling out, this is actually the explanation of why the minus rule works. So if you just wanted to do b to the 4 divided by b to the 6, because we know that when you are writing something as a fraction, that's the same as dividing it, right? Now the rule is, just like here, when we multiplied them and they had the same bases, we added the exponents, right? In the first example. Here, if you are dividing and you have the same bases, you're going to minus the exponents, but you always take the first exponent minus the second exponent. So you will do b to the 4 minus 6. Now what happens there, though, is that 4 minus 6 is negative 2, right? So you get b to the power of negative 2. And we can't leave answers with negative exponents, unfortunately. So we need to do this thing there, okay, where you have a negative exponent at the top of a fraction, because, guys, do you know that you can write anything as a fraction if you just put it over 1? Okay, that's quite a useful thing to do. So here, if we have b to the negative 2, we want to write it as a fraction. So we put it over 1 so that we can see that we now actually have to move that to the bottom. And then when we move the b to the bottom, the negative exponent will become positive. Okay, so there we end up with the same thing, that we have our b to the 2 at the bottom of the fraction. Okay, if you guys want me to do more of these types of questions, then I think what I'll do is I will post some TikToks where I'm actually working through them, so that you can see, or maybe a YouTube video. I can just work through some examples that are like these ones, okay? There are, loads of them that you can find online or in any kind of textbook, but I don't want to spend too much more time on this. I want to move on to the next one, which is also working with negative exponents, but just let me know if you guys want me to do more of these types of examples. All right. For number 3, here we have in square brackets we have a fraction, and then the whole fraction is raised to the power of negative 1. Now, this is a rule that you might have written down, or an exponent law that you might have written down separately, you might not have. But if you have a fraction that is to the power of a negative exponent, let's say negative n, because it doesn't have to be a 1 necessarily, it can be any negative number, then what you can do here is you can say that when you have a fraction raised to any exponent, you have to raise the numerator to that exponent and the denominator to that exponent. So a will then be raised to negative n, and b will be raised to negative n. But what did we just discuss? I just want to see if this is still on the screen. Let me just move it up a bit. Okay. At the top there, we just discussed that when you have a negative exponent and you want to make that exponent positive, you need to move it. So this a, we're going to have to move to the bottom. And at the same time, the b also has a negative exponent, so we're going to have to move the b to the top. So this is actually going to become b to the positive n over a to the positive n. Now guys, this is actually the same as b over a to the positive n. Just see if that makes sense to you. You have b to the n and a to the n. They have the same exponent. So what you can do is you can write just b over a and then raise that to the power of 1n. That same exponent. I don't know if you guys all knew that you could do this. Alright, this is often implied in the laws, but not necessarily understood that well, and this is actually something that you can do, okay? So if you have a fraction, and in that fraction, the numerator and the denominator have the same exponent, it's almost like you're taking that exponent out. Alright, then you can just take the numerator, the base of the numerator, and the base of the denominator, write it as a fraction in brackets, and raise the whole thing to that same power. We often do this. We often go this way around. We often say that if you have a whole fraction to the power of the same exponent, you can take the numerator to that exponent over the denominator to that exponent. But you can actually also work this way around. Okay, we'll get back to that. What I'm trying to actually show you here is that if we look at the first step, we have a fraction to the power of a negative exponent. That is actually the same as when we tip that fraction to the power of a positive exponent. That same exponent, which was negative n, now becomes positive n. Alright, so that is a law. You might not have it in your books, you might not have it somewhere. Please write this down. If you have a over b to the power of negative n, you can change that to b over a to the power of positive n. Okay, that is a law of exponents that some teachers don't write down as a separate thing. Okay, so please make sure that you write that down. That's very useful. So whenever a whole fraction, I'm just going to repeat what this means. Whenever a whole fraction is raised to the power of a negative exponent, you can swap that fraction around. In other words, it's like what we did here at the top when we tip and times. You can tip the fraction, swap the numerator and denominator, and then change whatever that negative exponent was to a positive exponent. Okay, that is what I've written over here. So now we're going to do that in this case. Alright, this whole fraction is raised to the power of negative 1. So let's tip the fraction, swap the numerator and the denominator, and then this exponent is going to become positive 1. So let's see, we're going to do that. At the top, we're going to put 2 to the negative 3. So whatever was at the bottom goes to the top, and at the top we had AB, that must now go to the bottom, and that becomes positive 1. Okay, so just look, this is what we're doing. We have, it might be a bit confusing because we have the same letters there, but let's just see, we have a numerator over a denominator to the power of a negative exponent. Then we can swap the numerator and the denominator around, and the exponent becomes positive. Okay, and that is what I've done here. Guys, notice that I'm not changing the actual fraction. I'm not changing what the numerator was when I turn it into the denominator. It was AB, I'm leaving it as AB. In the denominator, I had 2 to the negative 3. I'm not changing that when I move it. I'm just leaving it exactly as it was, and I'm just putting it in the numerator. Okay. The thing that is changing, though, is the exponent outside of the fraction. It was a negative 1. It's now becoming positive 1. Okay, now guys, if something is raised to the power of 1, you don't actually have to write that. Okay, so in the next step, I'm going to leave out these brackets and the exponent of 1. We don't need to do that. It's the same as when you are writing x to the 1. You don't have to write that 1. X to the 1 is actually just x. Okay, so in my next step, I hope it makes sense to all of you that I don't have to write those brackets and that exponent of 1 again. I can just leave it like that. Okay, so let's just ignore those brackets for now. What do we notice though? At the top, we have 2 to the power of negative 3, a negative exponent. We're not allowed to have any negative exponents in our answer. So that 2 to the negative 3, remember what we said earlier, when you want to change a negative exponent to a positive exponent, we have to move the whole power. So 2 to the negative 3, we are going to have to move to the bottom of this fraction. Does a have a negative exponent? No, it's just a to the 1, a to the positive 1. A is going to stay where it is. There's nothing wrong with the a. The same thing for b. B does not have a negative exponent. B has an exponent of positive 1. Remember, when there's no exponent written, it's actually positive 1. So the only thing that actually needs to move here is the 2 to the negative 3. So this 2 to the negative 3 is going to move to the bottom of my fraction. And I'm just going to write it next to what is already there. I currently have AB in my denominator at the bottom of my fraction. So when I move this 2 to the negative 3, I'm going to write it in front of AB. What's going to be left at the top? Remember, when we're moving something, all right, and I'm left with nothing there at the top, I can't just leave it blank. Okay, I'm actually going to be left with a 1 at the top. So this is what my answer is going to be, 1 over 2 to the power of positive 3 AB. Okay, so we see that this 2 to the negative 3 has moved to the bottom, and it becomes 2 to the positive 3. Now, I see I haven't left another extra line here for my answer, so I'll just write it next to this. But 2 to the positive 3 is actually 8. Remember, 2 to the 3 is the same as 2 times 2 times 2, which is 8. Okay, so let's just write our answer like that, 1 over 8 AB. Okay, perfect. That is the final answer. I'm just going to read some comments again quickly. I see someone said here that I already moved this to the top. Why didn't it become positive? Going from here to here is not me moving it. Alright, going from here, the question, to this first step is getting rid of that negative exponent. So notice that that is what changed. When you just swap the whole fraction around, right? Because see, I also didn't change AB when I moved it. Okay? I'm just swapping the fraction around. That is what changes. The negative 1 becomes positive 1. Okay, so this, going from the question to my first step, is not this red thing where I'm moving something to change the negative exponent. I'm actually swapping these two so that I could change that negative exponent into that. Okay, it's coming back to this rule, this law of exponents. Please make sure that you have written this down. Okay, when you are swapping them, so outer exponent becomes positive, you don't change what your numerator and your denominator was. You just swap them around. I'm still just reading. Yeah, let's not talk about Euphoria. I am going to go live for grade 8 next week, grade 8 and 9. I haven't quite decided which days. It depends on my schedule at school, which I don't know yet because I haven't gone back yet. But I will let you guys know as soon as I do. A little bit more to the side. Okay, I'll check now when I start again. Okay, I'm just going back down. There's quite a few messages now since I started reading. Guys, if you've joined late, just letting you know that I can't see my screen while I am teaching, so every now and then I just need to check for just need to read the comments. First time teaching grade 11 this year. You're welcome. Okay, let's see. The grade 10 lesson is on Friday. Okay, so someone's asking where this 1 is coming from here, because there wasn't a 1 there. So how it works is when you are moving stuff from the top to the bottom, see, because there was nothing else written at the top here. So if I move this 2 to the 3 to the bottom, right, then I would be left with that. Now it's almost a case of what is at the top? A nothing. Okay, but it's not really a nothing, because actually when you're moving this, you're actually dividing. Okay, when you're moving something from the top of a fraction to the bottom of a fraction, you are dividing by that thing. And in doing so, you're changing the sign of the exponent. So remember, when you are dividing something by itself, you are left with 1. Okay, but you can just, if there was something else, say for example, there was like an x in front or behind that 2 to the negative 3. If you then move the 2 to the negative 3 and it becomes 2 to the 3, you would be left with that x at the top. Okay, so it's only if you are moving and there's nothing else left, then you put a 1 there at the top. Okay. I do grade 12, yes. I teach matric, yeah. Okay, cool guys, we're going to move on to the next question. I just want to check that it is aligned properly. Okay, I hope you guys can all see that. Also, another thing, if the comments are distracting you, you can just swipe, I think, to the left. No, it's to the right, actually. I'm not sure. You can swipe to one of the two sides and the comments will disappear. Okay, now this type of question is very important for grade 11. Okay, in grade 11, you are going to do loads of these questions. Now, what we need to look at here is we need to see what type of question we're working with. What are they actually asking us to do? If we're just looking at the numerator, right, on its own, we're ignoring the denominator. We see that we have 2 to the power of 2n minus 1, so we have a base of 2 there. Okay, that's important. We are then multiplying that by something with a base of 4. Now, guys, if we go back to our basic exponential laws of what happens when you are multiplying powers together. Remember, if you have the same bases and you're multiplying them together, you can keep that base for your answer and then add the exponents. If we look at what's happening here, these two numbers do not in fact have the same bases. So as they're written now, I can't multiply these together. It's a very common mistake where people say that if you have a 2 to the power of something multiplied by a 4 to the power of something, many of you think you can just say, okay, 2 times 4 is 8. So I'm going to write an answer of 8 and I'm just going to add those exponents together. Guys, that is completely wrong. You can only add the exponents together if the original powers have the same bases. So like I have here, a to the power of m times a to the power of n, same base multiplied by same base, then you end up with the same base in your answer, and only then can you add the exponents together. You cannot add the exponents together if you don't have the same bases. Alright, that is a very common misconception. a very common error. So you have to have the same bases, which in this case, if we're looking at these first two, I don't have the same bases. I have a 2 and a 4. For the next one, I do have a times 2. All right, so that's useful. I can multiply these two together at least, but that 4 is still problematic. Then if we look at what's happening at the bottom, now remember, when you have a fraction, the fraction actually means that whatever you have at the top, everything at the top, so this whole product at the top must be divided by what you have at the bottom. So this, whatever this is going to equal or be equal to, must be divided by 16 to the power of n. Now remember what we spoke about earlier with the division rule. The division rule is that if you have powers that you are dividing, and again you have the same bases, then your answer will have that same base, and you will then say the first exponent minus the second exponent. Again, guys, you can only do that if you have the same bases that you're dividing. You can't do that here. For example, if I have a 2 at the top and a 16 at the bottom, I can't say that I'm going to take this exponent minus that one. They have to be the same bases. Okay, if there's anything that you take away from this live session today, it is that. Okay, you can only apply these exponent laws if your powers have the same bases. So what does that actually mean we need to do? In order to multiply all three of these and then divide by that, we need to make the bases the same. All right? So therefore, make the bases the same. And that is a very important skill when we get to exponential equations. We also have to be able to do that. Okay, so that is very important, guys. We need to make the bases the same. So at the moment, we have two bases that are already the same. So that's sorted. Just remember that when it's just written as 2, that's actually 2 to the 1. That's important. Please add that 1. Okay, we can't forget that this 2 actually has an exponent of 1, even though it's not written there. 4, we need to change. We need to try and write 4 with a base of 2 so that I can multiply it by these other parts of this product in the numerator. So can I write 4 with a base of 2? Remember that 4 is the same as 2 squared. 2 to the power of 2 is the same as 4. Now I'm just looking ahead because I know that I'm going to have to simplify this and then divide whatever I get at the top by 16 to the n. So in other words, whatever I get at the top is going to have a base of 2, right? Because all of my factors now, all of the parts of this product have bases of 2. So that means that my answer will also have a base of 2. Remember, when you're multiplying, your answer has the same base. So when I multiply a 2 and a 2 and a 2 and I add those exponents together, my answer is going to be 2 to the power of something. So at the bottom, I also need to write 16 as 2 to the power of something. And I hope that you guys know that 16 is the same as 2 to the power of 4. Okay, so that is what we're going to do, guys. We are going to, in our first line, rewrite all of the bases that were different, that were not 2. We're going to write them as 2's. Okay, so the first part of that product is fine. It's 2 to the 2n minus 1. I'm just rewriting that. Then we have times. Now this 4, I'm going to put it in brackets because 4 is 2 squared, but that whole 4 was to the power of n plus 1. Okay, so I'm going to put the 2 squared in brackets so that I remember that the 2 squared, this whole thing is to the power of n plus 1 because 4 was to the power of n plus 1. All right, and 4 is 2 squared. So look, I've just replaced my 4 with 2 squared. For the next one, times 2 to the 1. Then at the bottom, I'm going to do the same thing. 16, I'm just going to replace with a 2 to the power of 4. All right, so 16 to the power of n becomes 2 to the power of 4 to the power of n. Okay, now guys, just for doing that, you will already get a mark. All right, and that wasn't too bad. We all know that 4 is 2 squared and 16 is 2 to the 4. Okay, for the next step, Now, for these ones that have brackets, it is important that you realize that this 2 to the power of 2, that 2, we're going to have to multiply. It's almost like we're multiplying out a bracket. Okay, it's almost like this 2 is in front of a bracket here with this exponent. You can put brackets in there if that makes it easier for you. So this 2 needs to be multiplied by the n and by the plus 1. And here this 4 needs to be multiplied by that n. Okay, so the next step is us just getting rid of these brackets around these powers of 2. So we have a 2 to the 2n minus 1 over there times 2 to the power of 2 times n is also 2n. And then 2 times positive 1 is plus 2. Right. And then times 2 to the 1. Okay, so now we don't have brackets left in the numerator. That's good. At the bottom here we have 2 to the power of 4 times n is 4n. Okay, we've gotten rid of all of our brackets. Guys, doesn't that look nice? We have all bases of 2. Okay, so we can start working from there. What I'm going to do first is I'm going to simplify what we have at the top, because we know that when we multiply powers and they have the same bases, which we now have in this case, we add those exponents together. Okay, and our answer, if we look at this, when you have the same bases, you multiply them, your answer has that same base as well. So because we have a 2 times a 2 times a 2, those bases are all 2's, the answer is also going to have a base of 2. So it's going to be 2, and now I'm going to take that exponent. So 2n minus 1. Oh, excuse me. And then I'm going to add the next exponent, which is 2n plus 2. And then I'm going to add the next exponent, because remember that is what we do when we multiply these together. We keep the same base and we add all of the exponents. Alright, and that is all over 2 to the power of 4n. I'm just going to simplify this here because we have some like terms. We have 2n plus 2n is 4n, right? And then we have negative 1 plus 2, which is plus 1, positive 1, plus another 1, which is plus 2. I'm just going to go over that again. Negative 1 plus 2 is 1, plus 1 is 2. And at the bottom we have 2 to the power of 4n. Now guys, this might look complicated, but let's go back to the basics, alright? We are now dividing, and we notice that we have the same base. We have a base of 2 divided by a base of 2. What do we do when we're dividing and we have the same bases? We take the top exponent minus the bottom exponent, and we keep that same base. Alright, so again, our answer is going to have a base of 2. So we have our base of 2. We're going to take the top exponent minus the bottom exponent. Again, we notice that we have like terms, and it works out quite well in this case, because what is 4n minus 4n? 0, and I'm left with a positive 2. So 2 to the power of 2 is the answer, because we have 4n minus 4n is 0 plus 2, and 0 plus 2 is 2, and we all know that 2 squared is actually 4. So isn't that great? We have simplified this whole expression to a final answer of 4. Okay, I'm just going to read comments. I'm seeing someone saying here, I know I wasn't the only one who said 2 times 4. Yeah, no, honestly, I've been teaching for years, and most people do that. They say that 2 times 4 is equal to 8. Okay. I'm just going back down. People are asking if there will be a video. Yes, this whole live session is being recorded. It will be on my YouTube by tomorrow. I'll post it tomorrow morning. All that for 4. Yeah. Okay, let's see. Could you have also cancelled the 4 ends? Yes, you could have done it like that. Yes. And that comes back to, I suppose, what we did in the previous question. You could have cancelled them, yeah? Okay, cool, guys. Let's move on to the next question. Let me just remove my exam pad here. Ignore that. Okay. We might not get through all of these. I actually think I'm just going to do 5 and 6. And then we're going to call it a day. Okay. Number 5 is basically just a quick example to illustrate something that we're going to use in number 6. Number 6 is more the type of questions that you will be asked to do in grade 11. Now, what I want you guys to notice is that this question in number 5 is different from all of the ones that we've done so far, in the sense that we are now being asked to add these together. In the other questions, we were asked to multiply them. Then it would have been super easy, because then we could say, right, if they had said 3 to the x times 3 to the x plus 1. That would have been really easy to do, because now, let me just see, okay, it's still on the screen. It would have been really easy to do this, because then we could say, okay, we're multiplying, we have the same bases, so we are going to keep the same base in the answer, and we're going to add the exponents. So the answer would be 3 to the 2x plus 1. Okay, very simple. Guys, that's not what they're asking us in this question. In this question, they're asking us to add these two together. There is no exponent law for adding, all right? That might be a bit alarming, but I'll show you now what we're going to do. I'm going to just repeat that. There is no exponent law for adding. We have an exponent law for multiplying, which we have been practicing so far. We have an exponent law for dividing, which we have also been looking at. We do not have an exponent law for adding. But what we're going to do is we're actually going to be using this first exponent law as a tool in order to simplify this question. All right? So I'm just going to say that again, or I'm going to try and summarize what I've said now. There is no exponent law for adding powers with the same bases. All right? What we have here is 3 to the x plus 3 to the x plus 1. Now guys, if we had, I'll do it on the side here, if we just had 3 to the x plus 3 to the x, these two would be seen as like terms, all right? In which case, you would just say 3 to the x plus 3 to the x is 2 3 to the x's, and you would write your answer like that. I'm not sure if you guys knew that, all right? It's almost like when you say that x plus x is 2x. In this case, 3 to the x plus 3 to the x is 2 times 3 to the x. All right. Unfortunately, we also don't have that in this question. Now, what we're going to have to do is we're going to actually have to introduce something like this. We're going to have to try and change one or both of these so that we have like terms in a sense. All right. Now, I want you guys to look at, let me just get a different color. I want us to look at the second term, 3 to the x plus 1. Notice that we have a base of 3 and we have a sum in our exponent. We have an x plus 1. Doesn't that look similar to this? We have a base and then we have a sum in our exponent. Right? Now, what we've done so far is that when you have two powers with the same bases and two exponents and you multiply them, then you add the exponents together. But guys, we are actually now going to apply this exponent law in reverse. We are going to go from something that looks like this, a base and a sum in our exponent, to two separate powers with the same base and separate exponents that we are multiplying together. So I'm going to write it in blue on the side here. We are going to apply our product law for exponents the other way around, where we're saying if we have an exponent, also if we have a power and we have a base with multiple terms, a sum in this case, in our exponent, we can split that up into the base with the first exponent times by the same base with the second term of that exponent. Okay, do we notice that I have literally just written this rule that we've used so many times that we're all familiar with, and I've just written it the other way around. That is what we are going to do in this case. Okay, so let's see, I have 3 to the x plus this. I'm now going to split up. When I speak to my students about this, I say that we are splitting up the exponent. Alright, so basically we're going to do this. See, if we have one base with multiple terms in the exponent, we split it up into the same base with the first term of the exponent multiplied by the same base and the second term of the exponent. We're going to do that here. So we have our base of 3 to the power of the first term of the exponent. Then we split it up. I'm just going to use the dot. You can use the time symbol if you want. The same base with the second term of the exponent. Okay, I'm just going to write on the side here, if the question was this, 3 to the x times 3 to the 1, I think you all, let me just see, is that off screen? Yeah, let me move up, sorry. If I had written that as a question, I think you all would have been able to say, okay, this is easy, they have the same bases, I'm multiplying them, so I'm going to keep the same base, I'm going to add the exponents. Right? That's easy to do. I feel like all of you would have been able to do that. Now, I'm going the other way around. I'm starting with this, and I'm then splitting up that exponent. Okay, we're going to use it in the next question as well. Just move back. Alright, now, do you guys notice that we have a 3 to the x and a 3 to the x? Now, unfortunately, I can't just add these two together like I did here, because whether we like it or not, this 3 to the x has a 3 attached to it. Okay? But what we can do to simplify this, so like I said, we can't actually add them together in the traditional sense, where we say we have like terms, we're adding them together. What we are going to do is we are going to factorize here, because I have two terms and I have a 3 to the x in both of these terms. So what I can do is I'm going to take 3 to the x out as a common factor. And if that confuses you, don't worry, we're going to practice it a few times in the next question. Okay, we have a 3 to the x in the first term and a 3 to the x in the second term. I'm going to take the 3 to the x out as a common factor. And remember, when we take something out as a common factor, we actually are dividing each term by that factor. So if you have 3 to the x and you're taking out 3 to the x from that, you're actually dividing by the common factor. So what is 3 to the x divided by 3 to the x? It's 1, right? Plus, now I'm looking at my second term. If I take the second term and I divide by 3 to the x, I am left with 3. 3 to the 1, which is the same as 3. Okay, so now I have 3 to the x times 4, which is similar to this. Here I have 3 to the x times 2. It's better to put that number in front of the thing that has a variable. So I'm just going to write my final answer like this. 4 times 3 to the x. Okay, you were supposed to do this in grade 10. I hope that you all did. Like I said, in grade 11, they are going to test that, but more so in questions like the next one. Okay, I'm just going to read some comments again. Okay, so people are asking for me to just go over the factorizing step again. Alright, so if we look at this line here, I hope you guys can notice that we have two terms. Let me grab a different color pen. That is my first term, and that is the second term. Right, so when you take something out as a common factor, you divide each of the two terms by that common factor. So you write the common factor in front, then you're going to say the first term, which is just 3 to the x, divided by 3 to the x. 3 to the x divided by 3 to the x, that's something just divided by itself is 1. So the 1 goes in your bracket. Then you put your plus there. The second term, when you divide the second term by 3 to the x, I'll write it on the side here. I'll check now if it's on screen. When you divide it by 3 to the x, right, that is what happens. Basically, you can cancel it out. So you would just be left with a plus 3. Okay, and then all I did from there was I just simplified 1 plus 3, which is in the brackets, which is 4, right? 1 plus 3 is 4. And just instead of doing it like this, because you could have written it like this, I suppose, all right? You could have said that. You could have said 3 to the x times 4 in brackets. Okay, but it's better just put that 4 in front. Okay, it's like if you had a 4x as your answer, you wouldn't write x4, you would write 4x. Okay, so it's better to put the number just in front. Okay, we are going to practice it now again for this one. In both of these cases, in the numerator and the denominator. So hopefully then you will all be on track. Okay, let's look at the next one. Now for this one, in the previous question, we were adding, okay? Do we notice that in this question, we are in the numerator subtracting, and in the denominator, we're also subtracting. What we're doing here though, from the numerator to the denominator, remember when something is written as a fraction, that means that you are dividing. So what we have at the top, we have to divide by what we have at the bottom. Now what I want you guys to notice is that in this case, we have two terms at the top, two terms at the bottom. So I can't just cancel out stuff that I see at the top and the bottom. Alright, you can only cancel if you have one term at the top and one term at the bottom. I have two terms and two terms, so I can't just cancel out. Okay, if you do that, guys, you get a 0 straight away. That's a very serious error. Alright, I'm going to say again, you cannot cancel out if you have more than one term at the top or at the bottom of your fraction. You can only cancel if you have one term at the top and one term at the bottom. Alright, so now we are minusing. Guys, just like I said here, we don't have a rule for an exponent law for adding stuff with the same bases. We also don't have an exponent law for subtracting. Same thing here, we don't have an exponent law for subtracting. So we're going to do the same thing that we did up here. Do we notice that we have a 2 to the x plus 1? That 2 to the x plus 1, I'm going to split that fraction up. Same thing here, 2 to the x minus 1, I'm going to split this fraction up. So that I end up with something like this, which we had in the previous question, where you can factorize and then possibly cancel stuff out. Okay. Like I said, you're going to do loads of these questions in grade 11. So if you're a bit iffy on it, don't panic now, all right? You will be going through it in class again, and you will be doing work on this on your own. This is not the last time that you're seeing this. Okay, we're just revising. So here, 7 times 2 to the x, I'm going to leave it as it is. Alright, there is no exponent with multiple terms here that I can split up. So like in the previous question, we have a 3 to the x. I left that as 3 to the x because there's just one term in that exponent. Okay, I can't split an exponent up if it only has one term. Same thing here, I can't split this exponent up, so I'm just leaving it like it is. Minus 3 times, I'm just rewriting that 3. Now this exponent I'm going to split up. So I'm going to have a 2 to the x times a 2 to the second term in my exponent is 1. Alright, do we notice that it's similar to this one? Here I had a 3 to the x plus 1, which I changed into 3 to the x times 3 to the 1. Now I have a 2 to the x plus 1, so I take 2, that base, with the first term of the exponent, times 2 the same base with the second term of the exponent. Okay, over. My first term of the denominator, again, only has one term in the exponent, so I can't split that up. So I'm going to leave it as 2 to the x minus the second term in my denominator does have two terms in the exponent. So I am going to split this exponent up. So I'm going to take the same base. I'm going to take a 2 with the first term of the exponent times the same base 2 with the second term of the exponent. Guys, very important here is that the second term is -1. So we have to put a -1 there. In the numerator, right, it was +1, so there we have +1 as our exponent. In the denominator, the second term is -1, so the second exponent has to be -1. Okay, now we are going to factorize. Because, guys, the purpose of factorizing, I don't know if you learned this in grade 9 even, if it was explicitly said to you, but factorizing is actually a tool. It is a tool that you use when you are simplifying fractions. This is a fraction, okay? We need to use factorizing. That is actually why you learn how to factorize. In grade 9, you learn it as a separate section, but actually factorizing is there so that you can simplify algebraic fractions. Because, what did I say in the beginning? You cannot cancel out in a fraction if you have multiple terms at the top or multiple terms at the bottom. You can cancel out if you have one term over one term. So what we do is we use factorizing as a tool to go from multiple terms to one term. If we look at what happened in question 5, let me see. Oh, it is still on screen. Yeah. If we look at what happened in question 5, in this line, we had two terms. Then we factorized, and now we have one term. Because 3 to the x multiplied by a bracket, that is one term. So that is what we use factorizing for, guys. That is actually the purpose of factorizing, is so that in a fraction, you can take multiple terms, write them as one term, and then cancel out. So that is what we are going to be doing in this fraction now. I'm going to take a different color pen. I want us to notice that in the numerator, let's just look at the numerator first. We'll get to the denominator now. In the numerator, there is a 2 to the x in my first term, right? That is the first term of the numerator. This is the second term of the numerator. Do we notice that we have a 2 to the x there as well? So 2 to the x is the common factor in the numerator. So we are going to take 2 to the x out as a common factor. We write it down, then in brackets, we're going to write down what we get when we divide each term by 2 to the x. So 7 times 2 to the x, that is my first term. When I divide by 2 to the x, I'm left with 7. Minus, look at the second term, sorry. The second term consists of 3 factors here that we're multiplying together. It's basically a product of 3 parts. So if I now divide this product by 2 to the x, I'm essentially taking away that 2 to the x, and what is left? 3 times 2, which is 6. Okay, notice guys, here we had 2 terms, now we have 1 term. That is the purpose of factorizing. Okay, let's do the same thing in the denominator. Again, here we have a 2 to the x in the first term. The whole first term, in fact, is 2 to the x. And then in the second term, we also have 2 to the x again. So again, 2 to the x is the common factor in the denominator as well. So we're going to write 2 to the x, bracket. Remember, again, when we're taking out a common factor, we divide each term by that common factor. So 2 to the x divided by 2 to the x, all right, the term divided by the common factor is 1, minus, now if we're looking at the second term, this is a product that consists of 2 parts. So if I take the second term and I divide by 2 to the x, I'm left with 2 to the -1. Now guys, 2 to the negative 1 is a half. Okay, I'll write it on the side here. Remember, we practiced it on the previous page. If you have a negative exponent, you can write that over 1. Remember, I told you you can turn anything into a fraction by just writing it over 1. Now, how do we turn this negative exponent into a positive exponent? By moving it to the bottom of the fraction. When I move it, I'm not going to be left with anything at the top, so it becomes a 1. So that is 1 over 2. Okay, so this is 2 to the negative 1. Which is actually equal to a half. And if you aren't able to do that on your own, in your head, you can actually just type that into the calculator. We obviously want you to understand that, but in grade 11, you are not going to be asked explicitly to do that with a number. Okay, you will be asked to work with negative exponents in terms of variables, but if you're not sure if your answer is correct, you can just type in 2 to the negative 1. It will give you a half. Okay. Now guys, the important thing here is that now this is much easier to work with because now we have one term at the top. It's 2x times a bracket. That's one term. And one term at the bottom. 2 to the x times a bracket. So now, if we have the same thing at the top and the bottom, we can actually cancel those things out. Which is perfect because we have a 2 to the x and a 2 to the x. I can cancel them out. What is 2 to the x divided by 2 to the x? Anything divided by itself is 1. So those 2 to the x's have fallen away. Okay, now all that's left for us to do is to actually simplify what we have in these brackets. 7 minus 6, that's an easy one, right? 7 minus 6 is just 1. In this bracket, I'm left with 1 minus a half, which is just a half. Okay, perfect. We need to simplify this though. We can't leave a fraction in a fraction. Okay, you can't leave this as your final answer, unfortunately. We need to do 1 divided by a half. Now you can do this in 2 ways, guys. You can just ask yourself, 1 divided by a half. How many halves are there in 1? It's 2, right? Or if you want to write this differently, if you want to actually do it in your head, you can also obviously type this into the calculator, but they might say that you have to do it without the use of a calculator. Then you can write this slightly differently, right? You don't have to put this in. I'm just showing you that 1 over a half is actually the same as 1 divided by a half. And remember, when you are dividing by a fraction, then you would have to tip in time. So you would have to change this to 1 times 2 over 1. Okay, don't worry, I hope this isn't confusing you guys. I'm just showing you, if you weren't using your calculator, then this would kind of be how you would work it out. Okay, but basically you need to be able to divide 1 by a half and get to an answer of 2. Okay, I just want to check where we are for time. Alright, I'm just going to read comments. Okay, I checked now. I think you guys are talking about this one. Someone asked, can you write this as 12 to the x? No, you can't. Alright, because this is not actually a 3. This is a 3 to the power of x. Okay, this in itself, this whole thing, 3 to the x is actually a variable. It's not actually a 3. It's 4 times 3 to the power of a variable. Okay, so you cannot write this as 12 to the power of x. Okay, that is not allowed. If they have the same exponent, so if you have, for example, I'm going to write that at the bottom here. If you have this, 4 to the x times 3 to the x, right? Then there is actually an exponent law that you can, it's almost like taking out a common factor as well. Then you can write it as 12 to the x. Okay, but they have to have the same exponents actually. You can't have a 4, and then a 3 with an exponent, and then multiply those together to be 12. Okay. I'm just reading more comments. So what happened to the brackets was from here to here I actually worked them out. So 7 minus 6 is 1, and 1 minus a half is a half. Okay, so I actually calculated this answer to the brackets, and that I wrote there, and the answer to this I wrote over there. Okay guys, we are going to do the last one, and then that is it for today. The last one is tricky. Okay, you might not see many of these in your time, but yeah, if you see a question like this, I would love for you to be able to do it. And I'm going to teach you a trick as well. Now, what's happening here is, I'm sure you guys noticed that we have negative exponents, but what makes this question different from the questions that we did previously? Let me just show you the previous ones that we did on negative exponents. Let me just go back. Just want to make sure that this is lined up. Yeah, if you're looking at number 2, right, here we worked with negative exponents. And in this case, we just moved the b to the, well, actually here, all right, we first had to do it up in times, and then we moved the b to the top to make the exponent positive. We moved the c to the bottom to make the exponent positive. Same thing here in number 3, we had a negative exponent there, so we just moved it to the bottom to make the exponent positive. Now what I want you guys to notice is that in both of these cases we had one term everywhere, right? In this, now I know it looks very messy, just see if you can kind of see what I wrote through all the scribbles. But we have one term at the top and one term at the bottom, all right? We were allowed to move the C and to just move the B because we had one term only. If you have more than one term, you actually can't do that. All right, same thing over here. We just had one term at the top and one term at the bottom, so we could just move the 2 to the negative 3 down and simplify it, and that was our answer. When you have more than one term, however, you cannot just do that. Okay, that's very important. So I actually want us to write a little note here with number 7. So I am going to just make a little note here at the bottom. Numerator, so I'm going to write NUM for numerator. Do we all see that we have 2 terms? All right, 2 terms. In the denominator, we also have 2 terms, right? That's one term, that's the next. 2 terms. Therefore, cannot move negative exponents. Okay, maybe put brackets around that, highlight that. That is very important. Just move it up a bit. Okay, please write that down. That is important, guys. You can't just say, okay, this x to the negative 1 is going to move to the bottom, this y is also going to move, that x is going to move, that x is going to move. Okay, you can't do that. And the reason why we can't do that is because we have more than one term. Okay, in the numerator and in the denominator. So what we're going to do now is we are going to just rewrite each of these things that have negative exponents with positive exponents. But remember, we can't move them. So we're going to have to leave them where they are. Okay, but change the exponents. So here at the bottom, I'm just going to show you. X to the negative 1, right? If this was a question on its own, if we're just ignoring everything at the top, if you just had to rewrite x to the negative 1, you would say, okay, x to the negative 1 is over 1, so I can write it over 1. You don't have to do that, by the way, all right? It just makes it a bit easier to visualize that you must move it. So this is the same as 1 over x, x to the positive 1, right? So that's what I'm going to do, guys. In my fraction, I'm going to rewrite x to the negative 1 as 1 over x. Y to the negative 1 in the fraction, in this numerator, I'm going to rewrite as 1 over y. Now, it might be difficult for you to understand why you are doing that, or for you to understand the actual rewriting it, because you're a bit rusty on working with negative exponents, okay? So if you are struggling with understanding why x to the negative 1 is equal to 1 over x, then you need to watch this video back tomorrow when it's on my YouTube channel and go over the questions where we worked with negative exponents, okay? Because you need to be able to do this in order to be able to do this question. Again, don't stress if you're not 100% sure about this. You are going to practice it more this year, okay? And you can always go look at this video again. It will be up on my YouTube. So that's what I'm going to do here. In the numerator, I'm going to write x to the negative 1 as 1 over x, plus y to the negative 1, I'm going to write as 1 over y. So note that I have changed the exponents to positive, right? They were negative exponents. I've changed those exponents to positive, but I didn't move them to the bottom of the whole fraction because I'm not allowed to, because I have more than one term. Okay, now we're going to do the same thing here. Now guys, if we're looking at this on its own, I'm just going to write it at the bottom. Let me just check spacing. X to the negative 1y. This is one term on its own, right? X to the negative 1y, there. What has a negative exponent here? The x has a negative exponent, not the y. So the y is going to stay where it is. The x is the one that's going to move to the bottom. So this is going to become y over x. Right, remember I said earlier, I think it was with question 2. If you have like an x and a y in this case, only the x has a negative exponent, then only the x is going to move. The y is going to stay where it is. Alright, so x to the negative 1y, the y is going to stay at the top, the x is going to move to the bottom. The same thing here, when we have y to the negative 1x, in this case the y has a negative exponent, the x has a positive exponent, so the x is going to stay where it is, and the y is going to move. Okay, so I'm going to do that again in the whole denominator, in the whole fraction. I'm not going to move these to the top of the whole fraction. I can't because I have more than one term. So x to the negative 1y is going to become y over x. The x moves to the bottom, the y stays at the top. X has a negative exponent, so that one has to move. I'm going to put my minus there in between my two terms. I have y to the negative 1x, so the y goes to the bottom, the x stays at the top, so that becomes x over y. Okay, now this looks very complicated because we have fractions within a fraction, okay, which is not great. Now we call this a compound fraction. I'm going to move it up a bit because I want to write on the side there. Let's see, okay. This is called a compound fraction. Right, it's a compound fraction because we have fractions within the fraction. And a nice way of simplifying a compound fraction, which you might not have done in grade 10, some of you might have, but a method that you are going to have to use quite a lot in grade 11. You don't have to use it, but it makes it much easier when you're working with a compound fraction. To simplify that, the best way, the quickest and the easiest way of doing this, of simplifying this, but you have to memorize it basically, is to multiply every term in the fraction by the LCD of the inner fractions. I'll show you guys now what I mean by that. It might be a bit confusing if you've never seen this method before. Just write that down and then I'll show you. Okay, so for a compound fraction, where we have fractions within a fraction. And guys, even if you only have one fraction like at the top and everything else are not fractions, all of the other terms are not fractions, it still is classified as a compound fraction. Okay, as soon as you have a fraction or any number of fractions within a fraction, it's a compound fraction, and you can then use this method. So let's see, we have 4 inner fractions here, right? 1, 2, 3, 4. All of these terms within our bigger fraction are fractions, so we call these inner fractions. So now we need to figure out what the LCD of the inner fractions is so that we can simplify. Now let's look at all the denominators that we have. The first fraction has a denominator of x, so we know that x has to be in our LCD. The second fraction has a denominator of y, so y has to be in the LCD. So far we have an LCD of xy. Okay, I'm going to write that here. I'll write that at the bottom. So far our LCD is xy. Okay, I'm going to repeat that. First fraction has a denominator of x, so x has to be in the LCD. The second fraction has a denominator of y, so y needs to be in the LCD. Let's see if there are other variables in the denominators at the bottom that we also need to include. This fraction also has an LCD of x, but x is already in my has a denominator of x, but x is already in my LCD. Okay, I don't have to add another x. X is already there. My last inner fraction also has a denominator of y, but y is already in the LCD. I don't have to add another y. Alright, y is already there. So this is the LCD of the inner fractions. If this was an x squared, for example, you would have to put an x squared in your LCD. Okay, all of the variables in your denominators and to their highest exponents must be in your LCD. Alright, but we have covered all of the variables. It's just an x and a y, and the highest exponent of both of those is just x to the 1 and y to the 1. Okay, so that is our LCD. I'm just going to rewrite this line because it's a bit messy. So if we have 1 over x plus 1 over y at the top over y over x minus x over y at the bottom, my method of simplifying is saying that we need to multiply every term by this LCD. Okay, so take a different color pen. I'm going to multiply this first term by xy. I'm going to multiply the second term by xy. I'm going to multiply that term by xy and that term by xy. Okay, now this in-between step that I'm going to write now, you don't have to write. Actually, let me move it one line down so that it's not overlapping with that. If I have 1 over x times xy, right, this is actually going to happen. The x at the bottom is going to be cancelled out by the x at the top, the x from our LCD that we have now introduced there. Alright, so that x from the LCD is going to cancel out the x in the denominator. So what is then left? 1 times y is just y. That's great. We don't have a fraction anymore. Plus, I'll go over this again. 1 over y times xy. Now the y from my LCD is going to cancel out the y from that denominator. I'm left with 1 times x, which is just x. Now isn't that nice, guys? By multiplying each of these fractions by the LCD, I have managed to cancel out the fractions, essentially. I have taken away those fractions. Okay, at the bottom, again, I'll go over all 4 of these just now. At the bottom, I have y over x times xy. Again, the x from my LCD is going to cancel out the x from the denominator. I'm left with y times y, which is y squared. If I look at this one, minus, I'm just going to put that minus there. Here I have x over y times xy. The y from the LCD is going to cancel out the y in my denominator. I'm left with x times x, which is x squared. Again, I have gotten rid of all of the fractions in my expression here. Right, so I'm just going to go over this again. You look at your inner fractions. We had 4 of them in this case. You find the LCD of those, which was xy. Then you multiply every single term. Guys, even if some of these terms weren't fractions, you still would have to multiply them by the LCD. Okay, you're multiplying every single term by that LCD. And in doing so, all of your denominators in the inner fractions are going to cancel out. So here you have an x at the bottom, and then the x of your LCD will cancel out. So you're left with 1 times y, which is y. Here we have a y in the denominator, y from the LCD, those cancel out, so 1 times x is x. At the bottom, y over x times xy, the x from the LCD cancels out the x from the denominator. I'm left with y times y, which is y squared. Then I have a minus, and then here, x over y times xy, the y from the LCD cancels out the y from the denominator. I'm left with x times x, which is x squared. Okay, I'm going to say again, guys, this is a method that I always teach my kids. I find that it is the quickest way of getting rid of all of these inner fractions, is by multiplying every term by the LCD of the inner fractions. Okay, your teacher might show you a different method. That's fine if you prefer any other method that you want to use. I just find that this is a nice way of, in one step, getting rid of all of your fractions and ending up with terms that are not fractions. Okay, this is a difficult question, guys, so please don't panic if you are finding this difficult to understand. Like I said already, this video is going to go on my YouTube. You can go look at it again. You can listen to this example as many times as you need to, and I'm sure you can find some similar ones in your textbook. All right. Now from here, we still need to simplify this. Guys, still, we have 2 terms and 2 terms, so I can't just cancel out. Alright, now I'm hoping that this looks kind of familiar to you. At the top we have a y plus x. At the bottom we have y squared minus x squared. Now this is actually a difference of 2 squares. Alright, this is going back into factorizing. This is a question that you could have gotten even in grade 9. Alright, because not all of that stuff, but this. At the top we have a y plus x. And at the bottom, if I factorize y squared minus x squared, remember what happens when you factorize a difference of 2 squares. You end up with 2 brackets. You take the square root of the first term, so the square root of y squared is y. That goes into that bracket and that one. I just want to check my alignment. Here we go. And then you are going to have a plus in one bracket, a minus in the other, and then you put the square root of the second term. So the square root of x squared is x. So that goes into both brackets. Now what do I have here? Do we notice that we have a y plus x at the top and a y plus x at the bottom? I now only have 1 term at the bottom, right? At the top, technically, I still have 2 terms. But guys, to get around that, you can actually just put brackets around those 2 terms. Okay, now you've turned that into 1 term. You don't even have to do that, but you can if you want. Now you can just cancel that y plus x and that y plus x. I'm left with, what did we say earlier? When you've cancelled out everything at the top of your fraction, you're actually left with a 1. So I'm left with 1 at the top over y minus x at the bottom. And that is the final answer to this question. Alright, I'm going to say again, guys, this is a very difficult question. Don't feel bad if you are still not 100% sure if you understand what I did here or if you understand my method. Please don't panic about it. Okay, you won't get questions like these often. This really was one of the more difficult questions in the grade 10 textbook that I could find, and I thought that I would just show you so that you could see a different application of negative exponents, but please don't panic if you don't understand this. Alright, I'm just going to read some comments quickly. Sorry, I'm still reading. There's a lot of stuff that I missed. Some drama as well, I see. Okay, I'm just going to the bottom quickly. Okay, guys, I am going to call it there. Like I said, I'm going to post this on my YouTube channel tomorrow, and I am also going to start posting more content-based videos, like short clips on my TikTok later today, so you can keep an eye out on that. And yeah, I hope that this was useful. Like I said, if you struggled with this one, please don't panic. Hopefully you learned something. And all of this was a revision of grade 10, but in class they will also do quick revisions of grade 10 work before you go into the new grade 11 stuff. So hopefully you just have a bit of a head start now. Okay, good luck guys. I'll see you around. Thanks for being here.